Hey guys, welcome back. Dang, it's math time with Mrs. Mauro. Today we're going to focus on 8.2, graphing quadratics in the form of ax squared plus c. Our targets are going to be to identify characteristics of quadratic functions and also to graph and use quadratic functions in that form that you see here. Before we do anything else, let's go ahead and do a little review. So the warm-up for this day, one, is to find that intercepts show work on the margins if needed. So again, your notes are located in Canvas and you can also find them in OneNote. So what I would do is plug in my zeros. We're going to substitute. So we're looking for the x-intercept here. So that means I'm looking for this value. Y was a 0. And I have x plus nothing is 4. That means that x has to be 4. Then when we look for the y-intercept, we do the same thing, but now we're going to substitute in a 0 in for x. Add your y, and you get a 4. Well, there's only one thing that y can be, which is a positive 4. You can pause the video at any time, try the second, third, and fourth one there, and see if you guys remember how to do this. And then when you're ready to check, go ahead and play the video. For number 2, we're going to substitute a 0 in for y. So we're going to start with 0 is equal to x minus 11. In order to get x by itself, we have to add 11 to both sides of the equal sign. Therefore, x in this case is going to turn out to be 11. So the x-intercept is at 11, 0. Then we're going to go around and do the same thing, but for the y-intercept. So I'm going to plug in a 0 in for x. So y is equal to nothing minus 11. So, well, y has to be a negative 11. All right, and then also, if you think back, this is in the form of slope-intercept form, y equals mx plus b, but that plus means it's just whatever sign it happens to be. So if it's negative, there's your negative. All right, let's do the same thing over here. This is our y-intercept, so it's negative 13. And then if you're looking for the x-intercept, you can use the substitution. So y is a 0. If you solve 2 times y is a 0, x has to be a 0. The last one, same process. Y is a 0, so we're going to substitute in for the y. You have 6x minus nothing is equal to 12, so that nothing is really not needed. 6x is equal to 12, so 6 times what number is 12? Well, I hope you can see it has to be a 2. If you follow your algebra rules, you divide by the 6, x has to be a 2. All right, so we found our x-intercept, and the last one, this is in standard form, so if you can't see the y-intercept, just substitute. So x is a 0, so 6 times nothing is nothing, minus y is equal to a 12. Well, this disappears because we don't really need it, it's 0. So negative y is equal to 12. Now think about this. If a negative y is a positive 12, that means that a positive y has to be a negative 12. And if you want to follow your algebra rules, divide by that negative 1, and here's your negative 12. All right, we got the warm-up done. All right, so let's go ahead and start thinking about what we're going to be moving into. So this section is mainly focusing on what C does to your parent graph. So C is, let me just write it up here. We've got f of x, that's like your y, is equal to x squared. That's your basic quadratic function. But when we put an a value, that's going to change the width of your parabola. So it might make it narrower or wider depending on the value there. But here's what we're looking at today. We're looking at what C does to your graph. What is this value going to do? So here in this first and second problem, we're going to start off by graphing. And you guys can use Desmos to see what's happening, but I'm hoping you guys remember how to graph, how to make a coordinate, or how to use a coordinate grid by making a table here and plotting your points. So let's start off with the x and y table. And I'm going to make a second little y. This is going to be our g function. This is going to be our f function. This is just going to be generic. You'll see. And I'm just going to do something basic like -2, -1, 0, 1, and 2. Okay, so just to kind of save time, I went ahead and did the parent function. So here are my inputs, and I just went from -2 to +3. And so what this means is when I plug in an x or substitute it, these are my outputs, what my f of x is going to become. So when I substitute in a 0, 0 squared is 0. Substitute in a 1, 1 squared is 1. Substitute in a 2, 2 squared is 4. Substitute in a 3, 3 squared is 9. So I hope you can see where the numbers came from. So now I'm going to go ahead and do the function g here, the y's. So when you put in a 0, we get a 0, but then we're going to add 2. So 0 plus 2 is 2. So this is pretty much this part here for the parent function. And we're just going to add 2. So that's going to become a 3. Add 2, that's going to become a 6. Add 2, that's going to become an 11. And parabolas are symmetrical, so on the other side of the vertex, it'll be the same because it's going to loop back up. And here you can see I'm going by ones on my y, so if this is 1, it's just going to shift everything up by 2 units upwards. See, it's positive. That's your k. I hope you guys remember from functions that we've done in the past. And I cannot focus and talk here. I do this at the same time. All right, so when x is 2, this is going to be a 6. So 1, 2, 3, 4, 5, 6. Mirror image. So you can see the parent function is this one right here. And I'm doing my best. I know that's my best. And then here's the child function, function g. So it was translated up 2 units. So when you guys try yours, what do you think is going to happen to function g? What is function g going to do to your parent function? So this is your parent function. Notice it is right here as well. So what's that -2 going to do to your parabola? All right, and notice we also have an a value. So take a guess. Is that going to make, if you were to graph that, is that going to be a narrower graph or a wider graph in comparison to the most basic function, which is x squared? All right, so I hope you've checked it out in Desmos. And you should have seen or noticed that your graph is going to be moved down or translated down 2 units. All right, and I don't want you to forget the 0 of a function. I hope you guys remember that is where the graph intersects at the x-axis. So like in this case, I'm just using this over here. That would be a 0. This would be a 0. So it's the x value of the coordinate where the graph intersects at the x-axis. Do you guys remember that? It's also known as solutions, roots, all these different names for the same thing. Okay, so here we have a little bit of practice. We've got 4 questions, and it says to graph the function, compare the graph to the graph of this parent function x squared. So I've gone ahead and graphed in Desmos what the parent function looks like, and now we're just going to go ahead and graph the after one here, function g. So this is like our before, and what's our after going to look like? So if we make a table, all right, so I'm going to fast forward in my virtual world. Okay, so here is my table. I went ahead and just substituted in for x and then added 5. So when I substitute a 1, that's 1 squared, that's just 1 plus 5 is 6. 2 squared, that's 2 times 2, that becomes a 4 plus 5 is 9. So it's going to be mirror image, so this is going to be a 6 on this side and a 9 as well. I'm going to go ahead and graph them and then connect the. So now when we look at the comparison, we can just simply observe that function g takes our parent function of x squared and shifts it up 5 units. So it's a translation, and we want to say it's vertical, 5 units up. Hope you guys can do this. So you guys try number 2. Pause, be honest, think about it. What's going to happen here? All right, so number 2, hopefully you can see and observe that you are going to be moving the parabola 3 units down, and I've made my table over here. All right, for number 3, one of the things we need to recognize is that we have an A value that's negative, which means it's going to be flipped upside down. It's going to be a reflection on the x-axis. Notice it's -2, that means it's going to also be brought down 2 units. And I went ahead and did my table here of values, so I just kind of focused around the origin and substituted in my values. Remember that you have to use PEMDAS, so exponents, then multiply, and then subtract. All right, so I'm going to go ahead and graph my point. All right, so notice it's upside down, it's a reflection, it's opening down, and I wasn't able to graph the -14, but that's okay. I hope you guys get the idea. It's also more narrow in comparison to the parent function. If this was flipped upside down, this is a little bit wider. This is actually what's considered average or normal. This is the most basic, but this one here, notice it would be thinner, it would be inside. So this is going to also have a vertical stretch by a factor of 3 with a translation of 2 units down. Function j has an a value of a fraction here of 1/2, which means it's between 0 and 1, and that is going to be a wider parabola. Since it's between 0 and 1, think of it this way. It's trying to get closer to the x-axis, trying to get closer to 0, so it's going to be wider, as in comparison to number 3, we've got a value of 3, which is greater than 1, which is like a stretch. So it's trying to get closer to the y-axis. I'm going to go ahead and graph my values. I went ahead and did that. All right, so you can see it's wider, and it's also translated down 4 units. So 4 units translated down, and then it's a vertical shrink. It's a vertical shrink this time by a factor of 1/2. Nice job, guys.